So in today's lesson, we're going to be taking a look at rational exponents. Remember that rational basically means that we have a fraction. So here we have just a kind of a definition. Anytime you have some kind of base, so we're going to call the base a, raised to an exponent that's in fraction form, that's a rational exponent. And the way that we can rewrite that fractional exponent is in the form of a radical. So we have to be really careful with where we place each number. The numerator, which we're calling m, stays with the base a, so it stays inside the radical. The n, the denominator, becomes the index. All right, and there's actually a second way that we can write that because sometimes it's actually really convenient. You can actually take that m out and you can put the entire radical with the index in parentheses, and you can put that exponent outside. So basically that would mean that you would evaluate the parentheses first, and then you would raise it to the power, which in here is kind of the opposite. You would raise the base to this power and then take whatever root. So it depends on the problem that you're given. Sometimes one is more convenient than the other. So let's go ahead and jump into some examples. So I'm going to do a couple, well, more than a couple examples. So I'm going to label the first one A. All right, so we have 4 to the 3 halves power. All right, and what we want to do is we want to write it in radical form. All right, so using this formula or this definition, whatever you want to call it, what I know is that 4 is going to be the radicand, right? So inside the radical, I'm going to have 4. The numerator, which is 3, is going to stay with the base, so I'm going to have the third power there. And then 2 is my index. But remember that whenever we have an index of 2, which is a square root, we don't write it. So I'm not going to write it here. Now, this is going to be the square root of 4 cubed. So 4 cubed is a small enough number and we can figure it out. 4 times 4 times 4 is going to give us 64. And the square root of 64 would be 8. But I'm going to show you using this rule a simpler way to do that, using some smaller numbers. So I'm going to go ahead and use this rule here that lets me take this exponent and put it on the outside of the radical. So I can rewrite it like this, the square root of 4, and then I would cube that answer. So now the square root of 4, that's easy for us, right? We know that that's 2, and now we have 2 cubed, and 2 cubed is 8. All right, so either way, we get a final answer of 8. But this is just to show you that sometimes it's really convenient to put that exponent on the outside because you can do smaller operations or just less math first and then raise it to the exponent. All right, let's take a look at the next example. So we're going to take a look at negative 16. We're going to raise that to the 3/4 power. So once again, I'm going to go ahead and put this in radical form. Now what's important to note is that this 3/4 power only applies to the 16. This negative is technically a -1 on the outside. So you could technically write it like this, -1 times 16 to the 3/4. All right, so when you go to rewrite this in radical form, you need to keep the negative on the outside. So I'm going to go ahead and make my radical box. I know that this is going to be my radicand. 16 goes inside. 3, my numerator, stays with the radicand. And then the denominator is my index. So this is the -4th root of 16 cubed. Now you could do 16 cubed if you wanted to, right? 16 times 16 times 16. But that's going to be a huge number. So what we're going to do instead is we're going to put that exponent on the outside. All right, in this example, it's most convenient to do it that way. You don't always have to. So I'm going to have negative on the outside, 4th root of 16. So I'm going to do that first and then raise everything to the 3rd power. So let's go ahead and start simplifying. Well, what is the 4th root of 16? Well, that's 2, right? Because 2 times 2 times 2 times 2, 4 of those, equals 16. So I have and then I have 2 raised to the third power. So before I multiply this, I have to follow order of operations. I'm going to do my exponents first. So 2 cubed is 8. So when I multiply that by a negative, I get negative 8. Alright, let's try another one. C. This time we have in parentheses negative 27, all raised to the 2/3 power. So now this exponent does apply to a number that is negative. So when I write my radical, inside as my radicand, I am going to have a negative 27. So the parentheses make all the difference here. No parentheses in example B, but we do have parentheses in example C. So that numerator is going to stick with that negative 27. The denominator becomes my index. Alright, so here I could do negative 27 squared. It's going to be a huge number, so instead let's go ahead and see what happens if I do the cube root of negative 27 and then I square it. So the cube root of negative 27, I need 3 of the same number that are going to multiply to negative 27, and you might be thinking, well, there's a negative inside, it shouldn't work. But when we have an odd index, it does work. So in this case, the same number multiplied by itself 3 times, that gives us negative 27, is negative 3, right? Negative 3 times negative 3 is a positive 9, and positive 9 times another negative 3 is negative 27. So it does work out. So we have negative 3, and we're going to take that, and don't forget that we still have to square it. So negative 3 squared is a positive 9. Alright, let's try another. So now I have 1/9. So we have a fraction raised to a fraction exponent. So we have lots of fractions here. Alright, so let's go ahead and start a radical. I'm going to make this a pretty big radical because I have a fraction inside. Alright, 3 is my exponent, so I'm going to go ahead and raise it. I could probably just put that in parentheses since it's a fraction. And then my index is 2, so this is a square root. Alright, so I don't need to write, in fact I shouldn't write a 2 here. So I'm going to go ahead and use this rule again because I want to first figure out what the square root of 1/9 is. And once I have that, then I'll cube it. That's going to be the easiest way to solve this one. So the square root of 1/9, well, I can just take the square root of 1 and the square root of 9. I can do it in pieces. So the square root of the numerator, square root of 1 is 1. The square root of 9 is 3. So I've taken the square root, but we can't forget that we still have to cube it. Alright, so now I have to cube both the numerator and denominator. 1 cubed is 1, and 3 cubed, 3 times 3 times 3, is 27. Alright, we're going to do another example that is a little bit different. Alright, so we have 16, and we're going to raise it to the negative 3/4 power. So now I have a negative in my exponent, not in my base, right? Here, it was the base that was being multiplied by a negative. Here, this base was actually all negative. Here, the negative is happening in the exponent. So if you remember, when you have a negative exponent, we want to reciprocate and make that exponent positive. So before I start doing anything with radicals, I'm going to rewrite this as 1 over, right? I'm taking the reciprocal. And then I can rewrite this with a positive exponent. Alright, so now all of the work is going to happen in the denominator. So I'm going to go ahead and make a radical, and I'm going to put 16 inside. So the 3 is going to stay with my base, and my index is 4. Well, hopefully this seems familiar because we just solved it up here. Let's go through it one more time. So I'm going to do the 4th root of 16. I'm still going to use that rule up above. I'm going to solve that first and then cube it. So the 4th root of 16 is 2, and 2 cubed, I'll rewrite that here, 2 cubed is 8. So our final answer for this one is 1